Okay.
Are you ready to see what I'm going to make? So this lathe I acquired from my friend Craig 6 months ago.
$3.90. Oh, that was longer than 6 months ago. That was,
It was
like
at Christmas. So this lead screw goes in here. This is what moves this back and forth. But the thing that makes this special, as opposed to something I've made before, is that there's a gear integrated to it.
I believe you have something to make gears.
I do. Maybe we should refresh. Those and this made that. So this is the gear cutter to make that gear.
So we're remaking this.
Yes.
But you have one. So why do we need to remake it?
You are the biggest brain who leads these conversations.
I asked the best leading storytelling question.
The problem with this lead screw is that the threads are worn in this middle section here. And you can kind of see it because the threads are fat here. They get a little skinny, like their literal width is skinny, and then they get fat again. And this makes it hard to adjust the backlash in that screw. This wasn't supposed to go on here.
Wait, is that the tap that you spent an ungodly amount of time making?
Yeah.
Is it moving at all?
It's moving. It's not progressing. There's a difference. Actually, I know what I'll do. Yeah. Quit. Yo. Stuff. That's stupid. I left off here. Need to make this screw that has a gear. I have the stuff to make the gear, and I have the stuff to make the screw. But before I can make that, I need to make a nut that looks nothing like this. And to make this, I need a tap that I can get in there to make that. And so that's what this tap is. The only problem is, I was showing this to Craig the other day, and he pointed out that this is a left-hand thread. And this is a right-hand tap.
You get to make a whole nother tap?
I get to make a whole nother tap. You're gonna make the tap. I already made this one.
I'm not making a tap with you.
Let's go. Come on, girl. Let's go. All right, so I guess I'm on my own making this tap, but before we get started, I want to talk about something important to me. Legacy. This whole channel started because I inherited my late grandfather's machine shop, hence the name. But what I gained was more than just a bunch of tools. He left me knowledge, passion, purpose, and a legacy, which is why I'm excited to be partnering with MyHeritage. MyHeritage.com is the #1 genealogy website for building your family tree and discovering your heritage. And nothing builds a sense of legacy more than knowing where you came from. Now, even though I grew up with my grandparents, they never talked much about our family history, or if they did, I was more preoccupied with other things. But now that I'm older, I wish every day that they were still around so that I could hear their stories. MyHeritage can help with this. With over 20 billion records and documents like census lists, vital certificates, military records, and a whole lot more, MyHeritage makes it possible to piece together your family tree and figure out where and who you came from. You don't have to be an expert investigator to do this either. MyHeritage has software that deciphers these documents, even the handwritten ones, and starts making matches for you. So the more you find, the more connections you make, and the more you find. It's like the most productive feedback loop ever. I especially enjoy discovering old pictures I've never seen before, like these yearbook photos of my grandfather and grandmother from the 1950s. This is where MyHeritage really shines in my opinion. It's one thing to build a list of names, but to actually put faces to those names, well, it's just amazing. On top of that, you can even add your own pictures, and there's built-in photo enhancement to colorize and even animate your loved ones. Plus, with how many users are already on MyHeritage, it's common to find overlaps with other family trees that you can use to build your own. Every time I open the site, I find myself getting sucked into a literal rabbit hole, digging for more and more, and, well, it's just a lot of fun. So sign up for a 14-day free trial to try everything MyHeritage has to offer. Heck, you may even find out that you're related to me. Go to bit.ly/inheritance machining, or use the link in the description, or just scan this QR code to start your own journey into the past. And thank you MyHeritage for sponsoring this video. Alright, let's make that tap. We've already made one just like this before, only of the righty-tighty variety. I like that. So this is going to be a bit redundant if I don't gloss over some of the basic stuff like turning the shank and the outside diameter. Just like the last one, this will be a progressive tap, which means it's like 2 taps in one, hence the odd profile. On the bright side, I can actually take advantage of the 10 TPI Acme cutter that I made for the last lead screw project. But we can't forget the most important part of making this tap in the first place, the lefty-tighty bit, which just means I need to thread everything in reverse. After one minor boo-boo I was able to hide away, the threads are now in spec, but only in the rear section. Remember, I said I was making a progressive tap, so I need to take some more passes to make the threads narrower in just this leading segment.
Easy enough to do with some small adjustments to the compound since it's already set up parallel with the lathe. We have threads, but it isn't going to cut the cheese without any teeth. So over on the mill, I have a nice ball end mill set up for the task. A small note here. I only realized in hindsight that I set this up to cut the teeth for a right-handed thread, but it fortunately ended up giving me enough cutting edge on the other side where I needed it, so it all works out. After a quick square drive added to the end, we're ready to fire this bad boy up. Then a nice 400-degree temper for 2 hours. While that bakes, I'm going to get started on the rest of the lead nut that I made that tap for. That is a lead nut I have no idea what it looks like, so we got to get it out of the lathe, which fortunately only involves some minor disassembly and a slight shop expansion. What? It was easier than moving the whole lathe.
Alright, after going through all that to get this thing off the lathe, actually doesn't look that bad. And when I thread it on here, on this unworn section of the lead screw I do need to remake, there's not a lot of play. The backwash adjustment, maybe I should take that apart so you can kind of understand that. Hold please. And that actually doesn't look too bad either. So I may have just made a tap that I don't actually need. I guess we'll just go ahead and start making the lead screw.
This time around I'm making the lead screw from 01 tool steel as opposed to the 1144 stress proof I used in my last repair. Why the change? Well, I'm hoping to actually harden this sucker when it's all said and done, which will make it last quite a bit longer than otherwise, or so I hope. With the short little nubbins on the end to mimic the original, I can start working on the much lengthier threads, which obviously starts with slimming this whole thing down. But it's not as simple as that, of course. I need this shaft to be as consistent in diameter as possible, otherwise it's not much of an improvement over its predecessor. So as I near the final size, I'll check that things are coming out straight, which of course they aren't, but nothing my precision hammer can't remedy. Some small adjustments to the tailstock should get this right. Within half a thou is probably as good as anyone could hope for on this lathe, so let's work on those threads. You've probably gathered that this will be a left-handed thread as well, so I need a starting point on this end for the thread cutter. And might as well die cut the whole thing because it makes this next part look way cooler. Now before I get too far, I should point out something that, well, I only just thought of. With how long this thing is, thermal expansion is probably my greatest enemy. Most steels expand about 7 microinches per inch degree Fahrenheit, basically saying that for 100 degrees in temperature rise, which doesn't seem that unreasonable here, this 10-inch long shaft is lengthening 7/1000ths of an inch. And cutting a thread in a shaft that is constantly changing in temperature and also length definitely isn't going to result in anything close to precise. So I need to make sure I let this thing cool down before taking the final passes. Heck, just look at how loose everything is after letting it cool down for just a few minutes. Let's snug it up and keep moving.
Alright, basically everything I was trying to avoid, I didn't. I measured with the 3 wires, and here I'm about 5 thou above my target, which is fine, I can still cut it. Here I'm about 12 thou above my target, which is a little concerning. And then down here, I'm already 4 thou under my target. This got too hot, exactly like I was talking about. This end extended, and then I took some passes, cut these threads too narrow, so this end is basically shot. There's also another problem. The tap that I made, I missed one critical element in it. I made it basically exactly the same size as this thread. You need some clearance on the OD. The only part of the thread you actually want touching are the two slanted faces on each side of a thread tooth. And so I made this exactly the same size. So when I do a test cut, like I make a test block, a nut, it goes on, only because we're under spec here, then it starts binding up almost immediately. And I've given myself no clearance in my test block because the tap that I made is too small. The angled faces of the threads are right. I've not left enough material to cut the clearance on the OD. So it's a good thing I'm not making a new bronze nut, because I'd have to make a new tap, I think. Actually, let me see. I'm gonna make the OD of this like 5 thou small, just to give me the clearance for a nut in the event that I need to remake a nut. And then I'll bring in the follow rest to prevent this from deflecting all over the place. And I'm going to try and figure out some sort of coolant situation. Maybe steal some coolant from one of my other machines, just to get through this part.
All right, I'm going to take the quickest route to get some cooling capabilities on this machine, and that's by stealing it from another. The surface grinder already has a standalone coolant setup that's just a matter of a few snipped cable ties, so it's the obvious choice. It's also easy enough to stick under the lathe chip pan, which already happens to have a drain built in, so I just have to direct that into the coolant reservoir, fasten the nozzle to something, like the old nozzle, and we're in business. Countermeasure number 2 is as simple as mounting the follow rest on the carriage. Let's give this another go. Okay, I really like turning with coolant. Not only is this actually keeping the shaft nice and cool, but the finish is just mwah. I am getting a little deflection in the middle, but again, I've got the perfect antidote for that with the follow rest. I just have to be sneaky and bring the paws in only after they clear the live center. Let's take another stab at those threads. We're getting close to the final size, so it's time to start using the follow rest here as well. There's a pretty gnarly burr along the entire length of this thread though, and I'm not sure how well it will jive with the rest paws. So I'll spend a little time with a file clearing this away. Now this is a bit hairy since I can't stop the thread feed until I pass the end, but I can't reach the end without retracting the follow rests lest they crash into the tailstock. So I just have to be real quick about backing those out and pulling on the right lever. No, not that one. Well, that actually wasn't that bad. Sure, I gouged the hell out of the live center, but somehow the Acme cutter came out completely unscathed, albeit a little crooked. So I'll just get this squared back up, and of course now I have to get the cutter back in line with the groove, which I can do by engaging the feed and using the cross-sliding compound to get everything dialed back in. Now I can pick up where I left off, making absolutely sure I'm yoinking on the correct lever this time. Well. Given all the variables that went on here, I didn't think I would get it even remotely this close, but I'm basically within 1 thou of the right size everywhere I check on this shaft. The coolant and follow rest certainly made a huge difference, and the lead nut goes on without an issue. Let's move on to the rest. The rest of this shaft, I mean. Starting with the integral gear. I'll use the forge awl this time so I can guarantee concentricity with the area that rides on the support bearing. And of course, once everything's lined up, I see that the shaft is completely banana-fied. I'm going to leave that problem for future me. With that to size, we can start on the fun stuff. And if you've been following along for the last couple months, you might be starting to connect some dots. 2 months ago, I started on something called the Eureka Gear Cutter. Making that and combinations of specialty button cutters like this has let me make this, a gear cutter, specifically sized for this exact operation. 0.75 module, 24 tooth, 20 degree pitch angle, and a lot of freaking build-up. So let's put it to work. I'll just verify that the depth is good before we work through all 24 teeth and make a slight adjustment, then we're on our way. Now the ideal setup for this would be something like a dividing head, but fortunately the math works out easy enough for a 24 tooth gear. So it's just 15 degrees at a time as I work my way around, and well, I think you get the rest. Well, I probably should have double checked after that last adjustment because everywhere I measure is still too large. One more go around it is, but this one is much less exciting because it doesn't look like I'm doing anything. That is the number I wanted to see. So that's the teeth, but also a ton of burrs we have to get rid of, so back to the lathe. Okay, with all the burrs removed, this seems to be doing its geary thing. Let's finish this bad boy out. When I flip this around, I need some sort of reference, so I'll use every machinist's favorite scribing device and mark my length. Then do the 180 and true everything back up for the final set of diameters. Now for the penultimate operation, just a short metric threaded section, which should be a breeze given the struggle I just went through on the other end.
Somehow I didn't lose my mind at this. I'm sure some of you noticed exactly what I was doing wrong there, and I completely spaced. This doesn't look right, does it? That's because it's not. This is a metric thread, and on most lathes, including mine, you don't cut them the normal way. You have to forward and reverse, as opposed to just pass, pass, pass. I have no idea how I made it through 5 passes before realizing how off I was, but the result is I basically have nothing left here. I might be able to salvage this, making it a different size thread. I don't want to get this far and have to start over. Don't have any more material to do this with. So let's just do a think.
Okay, thinking complete, and I have a plan. A 3/8 24 thread is just a bit smaller than the botched OD of the 10mm thread I just tried to cut, but also still larger than the ID of the base diameter of this shaft. All that is to say, I think I have just enough material left to do something with here. Well, that certainly looks like a thread, and judging by the way this finely engraved test block goes on here, it acts like a thread too. I think we can call this a success, which means with the exception of a couple of center drills on the side, we are done.
We meet again.
The Hoochie Daddy shorts have returned. This time we have the Hoochie Daddy shirt as well, though.
It's not any more hoochie than my other shirts.
Yes, it is. It's
Okay.
the same in the torso, but the arms are much smaller. So we
You saying
see.
I have small arms?
No, I'm saying that the sleeves are much smaller, so the girth of your arms is more apparent.
Girth.
Yes.
Speaking of girth, I have something to share with you. My
More
shaft.
metal. That's more metal and less flesh than I was
Okay.
expecting.
Come closer so that you may see. They knew what they were doing because they named it the hot rod.
Oh my goodness.
Okay, for people watching, this is an induction heater.
This is so that you don't use an entire tank of your oxyacetylene torch to heat this thing up.
Hopefully. The idea is that it uses electricity to heat up my shaft.
Is that going to fit through there?
Yeah. Oh, good point. It will be tight. Bigger induction coil.
Okay.
And the idea is that this should heat it up very quickly. And I'm hoping that I can just sort of...
Would it be worth trying it on the botched one first?
Yeah. Good idea. You're going to plug it in and you're also going to press the button.
Press it?
Hold it. Yep. Well, there's smoke, which is probably the oil coming off the thing. I don't like how slow this is going. The idea is that I need it to be red hot when it hits the oil. This isn't going to work.
Okay.
I guess it's back to the flames. Okay. Would you like to see what I made, sweetie?
I would love to see what you just showed me how to make.
So I just made like a trough, a little castle with bricks, with some suspendy things for me to heat this up with a torch. Ooh, fire. Thank goodness for editing. I've been heating this thing for like 20 minutes. We are sufficiently red on the threads only.
Okay.
We'll come back to the gear. Okay. Ready, set. I did not account for displacement here. Ooh, it's a banana. It's literally got an 1/8 inch of bow in it.
Can you fix that?
We will see. I guess we could try doing the gear.
It's your call.
I mean, it's already kind of... I might have you rotisserie this thing.
No. I see some cherry red.
Yeah. This is freaking working.
It is very banana-ish though.
It may straighten out in the heat treat. That's some false optimism, but... All right.
Oh, we'll go toast it in the oven and see what happens.
So after copious amounts of time on the wire wheel and even scotch brightening this thing to death on the lathe, we've arrived at this. A pretty clean looking banana. Yeah, the tempering cycle did diddly to straighten this sucker out. So we're going to have to do that manually. To get some sort of an idea of the progress, I've got a couple V-blocks to set this thing in with an indicator. And it looks like we're starting around 75 thou of run out. Should be no match for the hydraulic press.
That is so dumb.
Oh, sweetie. No.
It's fine. Well, I mean, it's all in one piece.
That is marginally less useful than the shaft that you already had.
So it was warped just from the machining. It was just 01 tool steel. But then it warped more
Really bad, like visibly.
when I quenched it. So I was trying to bend it back. On the bright side, it's very clear I hardened it. The most perfect brittle fracture.
Yes.
So these are hardness files. If it doesn't scratch it, it's harder than 65. And it kind of bites a little bit. The 60. It just skates off of it. So it's somewhere north of 60, somewhere south of 65 Rockwell hardness. It's definitely hard. It's also hard on the emotions.
That's very sad.
Hard on the ego. Hard on my heart. I think this is what I get for working in the machine shop with my sweatpants and slip-on shoes as opposed to my work pants and leather boots.
This is not a serious outfit.
Craig asked how hard it was. I said probably like 64. He said you probably need to be in the mid-50s to be able to bend it back without it breaking.
So could you have annealed it for longer?
Yes, or at a higher temperature.
On the bright side, you're very good at hardening things.
Practically a professional at it.
So now what's the plan?
End the video.
Okay.
So yeah, that actually happened. It's been a few days since the incident, and I'm not exactly sure what to do next. I'd hate to just start over and do the same thing again and just end up in the same place. So I'm wondering what you guys think. Maybe there's a better order of operations. Maybe there's sort of stress relieving operation I can do before I even start machining, or maybe I just need to do a different heat treatment cycle. So yeah, I'm at a loss. Leave me a comment if you've got an idea. Maybe we can figure this out. Also, don't forget to check out myheritage.com. I've got a link in the description. This is just such a powerful tool, even if you're just casually interested in your ancestry. And even if you just do the 14-day free trial, it helps enormously with getting great sponsors like MyHeritage to support the channel. Anyway, that's all I got for now. Thanks for watching, and see you next time.